The problem is a lot of times scientists are so entrenched in what they think they know that they don't realize that often a lot of what we know is wrong.
Dude, what's your favorite thing about Mars?
About Mars?
Yeah, it's a nice shirt, by the way.
Mars who?
Mars, the red planet.
Oh, I'm be honest with you, I really don't know.
Probably the iron oxide dust.
The iron oxide dust making it
red.
No, it's red.
Red?
It's gigantic.
How big is it?
What is it, like 20 times the size of the Earth?
I love what I imagine to be the silence on Mars.
What do you know about Mars?
I know it's a planet that ain't got shit out there.
I don't know. It's like there's oxygen in it.
I like how it's yellow and somewhat red.
That it's red.
It's red? Yeah, Mars, what do you think?
It's red.
Martians.
Mars. For millennia, we've looked at it from a distance. Just a red dot in the night sky, wondering what's there. And thanks to countless advancements in science and technology, NASA finally gave us our up-close look.
In the 1970s, NASA made a big push to explore the solar system with robotic spacecraft, and Mars was the primary destination. And so we sent many missions, the Mariner missions and the Viking missions, to Mars to see what it was like. And up until then, we didn't know very much. We only had fuzzy pictures from ground-based telescopes that showed a red ball, and sometimes it had, different colors on it, and it showed the ice caps in white and what we thought were dust storms going across it. So when the first robotic probes got there, took detailed images, we weren't really sure what we were going to see. And what we found was desert.
Here's Mars today. At first glance, there's nothing. No water, no trees, which is weird because despite being roughly half the size of Earth, its axis tilts the same way and even shares a 24-hour day. Nights are well below freezing, but sometimes it gets as warm as 95 degrees Fahrenheit at the equator. It's even got polar ice caps, 2 tiny moons, and a bluish sky, as seen here in a landing video for the Perseverance rover.
The navigation has confirmed that the parachute has deployed.
But still, it's just a desolate landscape. The question is, was it always this way?
If we were to go back in time, let's say 3 billion years ago, we may have been able to see scenes like you see right here in Santa Monica, where there could have been an ocean, for instance, that may have covered the entire northern hemisphere.
David Page is professor of planetary science at UCLA and principal investigator for several NASA experiments on the Moon and Mars. He was awarded NASA's Exceptional Scientific Achievement Medal in 2013 for breakthrough discoveries in the thermal stability of volatiles on the Moon and Mercury.
There could have been beaches, there could have been clouds, there could have been all kinds of things that we might associate with a living planet.
Did Mars have water on it?
Enormous amounts of water. It had enough water to cover the entire surface to a depth of 400 yards.
Where'd it go?
Some of it went down into the subsurface and is still there. And much of it was lost to space when Mars suddenly lost most of its atmosphere and the water just evaporated into space.
The recent discovery of deep subsurface lakes.
Yes, there are deep subsurface lakes on Earth. There are deep subsurface lakes evidence on Mars.
Most people think that we're still looking for water on Mars.
That's nonsense.
Richard Hoover was a research professor and astrophysicist at NASA's Marshall Space Flight Center from 1966 to 2012. He has 11 patents, and in 1992, NASA selected him as their Inventor of the Year for his invention of the Water Window Imaging X-ray Microscope. He led their astrobiology research department until his retirement, and he now volunteers at the U.S. Space and Rocket Center in Huntsville, Alabama.
The polar caps of Mars are frozen H2O. Frozen H2O is water. You may call it ice, but that's water. All you have to do to change its state is apply a little bit of heat.
There's still water on Mars now, but there used to be a lot more. And as far as we know, water plays an important role for the development of
the L word.
Yes.
It can be a contentious word.
We don't really know exactly how life originates. This is one of the biggest mysteries in science, and we may never know how life originates, but we know there are some crucial ingredients. Certainly liquid water is very important for life as we know it, but also organic molecules and a source of energy are all important. We would love to find life on Mars. We'd love to find UFOs. We'd love to find any kind of life outside of what we find on the Earth. That would be probably the biggest scientific discovery of all time. And it would tell us so much about our own origins, which of course is one of the major questions of science.
Is it possible that life developed more quickly on Mars than it did on Earth?
I'm not even sure it developed on Mars. I'm not sure it developed on Earth. Life may have developed somewhere else and been brought here. Life in our solar system may be the result of biological contamination from another star system.
What Professor Hoover is referencing here is known as
panspermia. Is the idea that life that originates in one place, maybe in the solar system, can then spread to another part of the solar system. So one example would be what's called lithopanspermia. So imagine 65 million years ago, big old asteroid hits the Earth, kills the dinosaurs, but in that impact, many rocks are going to get launched into space. Those rocks will have life on them. They'll have microbial life inside, they will have, bits of stuff stuck to them. And that rock will then go flying through the solar system. Now, space is a very harsh environment. Anything on the surface almost certainly would have been sterilized. But perhaps inside a crack in the rock, something could have survived. And if that rock were to have landed on Mars, then it might have a chance for that life to go and spread there. So if this happened billions of years ago, we could imagine that Mars might have been wet and gotten some Earth life, and there could be Earth life on Mars. Or it could be that life actually originated on Mars and that it was transported back to Earth, and that we are all in some sense descendants of Martians. That would be kind of cool.
It turns out that bacteria in space freeze dry, turn into spores, and they can last in a dormant state for millions of years. Then when they land on a good planet, they can double every half an hour. So 2, 4, 8, 16, and so on. They can take over a planet in about a year.
As far as evidence is concerned, the game is up. All of the evidence is in place. There's not the slightest doubt in my mind, or in the mind of any intelligent person, that panspermia is not the answer to the distribution of life in the cosmos. Denying it is a matter that is entirely political, and it would not last more than maybe a decade at most. I think evidence eventually trumps everything else, and the evidence is there. Evidence is getting stronger by the day, even by the minute.
Professor Chandra Wickramasinghe studied at Trinity College in Cambridge, earning his PhD in mathematics in 1963 and a doctorate of science 10 years later. Wickramasinghe has written over 40 books, published over 400 technical articles, and is currently an honorary professor at the University of Buckingham. Together with the late Sir Fred Hoyle, he's best known for popularizing the panspermia hypothesis.
From all the evidence that we have accumulated, there's absolutely no evidence for life starting on the Earth. That's 100% certain, 100.000% certain. So Aristotle, forget about him. He was all wrong. There was no way in which you could generate fireflies from a mixture of warm earth and morning dew. any more than you can generate bacteria from a mixture of chemicals. Scientists have been trying to generate life from non-life in the laboratory, and it's been a dismal failure. Every single attempt has led to a zero result.
The most well-known evidence supporting the idea of panspermia was discovered in a meteorite found in the Allen Hills of Antarctica in 1984.
I started the astrobiology group at the NASA Marshall Space Flight Center. The entire astrobiology program was started after David McKay announced the discovery of possible microfossils in the Allen Hills meteorite that came from Mars.
Today, Rock 84001 speaks to us across all those billions of years and millions of miles. It speaks of the possibility of life. If this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever uncovered. Its implications are as far-reaching and awe-inspiring as can be imagined. Even as it promises answers to some of our oldest questions, it poses still others even more fundamental. We will continue to listen closely to what it has to say as we continue the search for answers and for knowledge that is as old as humanity itself, but essential to our people's future.
While the Allen Hills meteorite is the most well-known meteorite containing what many claim to be a microfossil, it wasn't by any means the first discovery, nor the best example of microfossils in a meteorite.
After David McKay made this astonishing announcement, I said, this is crazy. Everybody knows there are microfossils in meteorites, because I knew there were microfossils.
You already knew?
I already knew. I had written about it in a paper I did with the late Sir Fred Hoyle that was published in 1986. But we don't know exactly when they landed on Earth. But when you see one, like the Orgueil meteorite that landed in France in 1864, gigantic fireball seen and heard over all of southern France, and pieces rained down. Madame de L'Epiroque thought her chateau was completely ablaze. She thought it was the end of the world. The next morning, when she walked out on her garden path, there was a stone lying there that was white. What is this? And she then realized that the white was frost. On the 14th of May, 1864, in the morning, you don't find frost on rocks. This is the south of France. And yet, this rock was covered with frost. And underneath that frost was a jet black Ci1 carbonaceous chondrite, one of the most precious and wonderful meteorites on the planet Earth, the Orgueil meteorite.
Professor Hoover cracked it open and took a closer look.
So, here we have two complete diatoms, complete top half and bottom half together. Very, very rare to see this in the fossil record. And these were inside a freshly fractured piece of the Orgueil meteorite.
Diatoms. Microscopic plant life that produces much of the oxygen we breathe here on Earth. They're incredibly porous and are used for swimming pools and beer brewing for their excellent filtration qualities.
Diatoms are among the most wonderful and most beautiful plants on Earth. They live not only in all of the oceans and rivers and lakes and streams, they are the most abundant plants that live in Antarctica.
What do you say to other scientists who claim that your research was simply contaminated?
The answer is, it is not possible. The absence of DNA and RNA is clear and convincing proof that these meteorites are not contaminated by modern biology. The missing amino acids and the missing nucleobases, clear and convincing proof. They're not contaminated by modern biology.
They just don't want to hear it.
Exactly.
So, I understand no one has debated you openly about this. Is that correct?
I'm willing to debate anyone, anywhere on Earth, at any point in time.
Why don't you think they want to debate?
Well, because they can't answer the question that I just raised. How do you contaminate a meteorite without putting in all 20 protein amino acids and all 5 nucleobases?
So the Allen Hills meteorite
was much later. Much later.
Most people think that was the first.
No, absolutely not. Absolutely not. And meteoriticists did not like the idea of biology in a meteorite. I found a fragment of something that might be a diatom in the Murchison meteorite, which landed in Murchison, Australia in 1969. But in 2012, on the 29th of December, there was a great fireball over south central Sri Lanka up on a mountaintop. Lots of people saw it. There were explosions. They heard these explosions. They saw the fireball. And then stones started falling out of the sky like twinkling fireflies as they came down, blinking on and off, and landed around the villagers in the areas of Arlaganwilla and Dumbalala and various other tiny villages in north central Sri Lanka.
Someone on the internet said that in Sri Lanka, the poor farmer wouldn't know the difference between cow shit and a meteorite, right? So we got to disregard this. And the fact is that the most powerful laboratories, geological laboratories, both in Sri Lanka and in Britain and elsewhere, have examined this, and it's certainly not cow dung.
Volanarua stones are clearly extraterrestrial. They have oxygen isotopes that are not like any rocks that appear on Earth, not like any rocks found on the moon. They have minerals that are formed under incredibly high pressures, the kind of pressures you get when asteroids collide together.
It is a rock imbued with elements, isotopes that are alien to the Earth, and imbued also with evidence of diatoms, microscopic life forms that are embedded within this meteorite. There's no chance that it is a piece of Earth rock or anything on the Earth.
If microscopic life is likely found embedded in meteorites coming from space and landing on Earth, and maybe starting life here on this planet, what are the chances the same happened on Mars? Is there any evidence of microbial life on the red planet?
The first evidence of life on Mars came during Viking.
The Viking biology experiments represent a pioneering first effort in the search for life on another world.
And that was with Gil Levin's result on the label release experiment on Mars.
He put a life detection experiment on Mars and discovered that there was evidence, absolutely clear-cut evidence, according to Gil Levin, of active microbial life.
In the future, when all is said and done, I'm sure my father will be credited with discovering biology on Mars.
Dr. Ron Levin earned his PhD in physics from Johns Hopkins University in 1982. He's currently an engineering fellow at Raytheon Technologies. Growing up, Ron could often be seen at NASA's offices alongside his father, Dr. Gil Levin. Dr. Gil Levin, sadly, passed away in 2021 at the age of 97. A World War II veteran, he earned his bachelor's degree in civil engineering in 1947, his master's degree in sanitary engineering in 1948, and finally his PhD in environmental engineering from Johns Hopkins University in 1963. Among his many awards, patents, credentials, and other scientific achievements too extensive to list here, he was also an honorary professor at Buckingham University's Center for Astrobiology in the United Kingdom. Given his extensive background in engineering and public health, NASA selected him to design a life test experiment for the Viking mission in 1976. Joining him was Dr. Patricia Ann Stratt, who was the first female investigator of any Mars science mission. She was invited by Dr. Gil Levin to work as his co-investigator on the Viking labeled release experiment, working side by side with engineers to develop the instruments, test designs, and conduct data analysis. Prior to working with Dr. Levin, she earned her PhD in biochemistry from Johns Hopkins University and was part of NASA's 1971 Mariner 9 mission.
We could have said, we've detected life, hung our hats up, grabbed a bottle of champagne, and celebrated. But that was not to be. Finding life is such a sensational thing that even if you've previously agreed on the test, when it actually happens, you double think. And NASA and other scientists double thought. And they said, no, we still believe it's something else.
His experiment was sensitive to as little as 10 living microorganisms in a cubic centimeter of soil.
Tell us about Dr. Gil Levin.
He was a great man, great scientist. He designed one of the life experiments that was sent to Mars as part of the Viking landing experiments in 1976.
What did it find?
Life.
How do you know?
I looked at the results. He knew it, and then they were overruled. They said, no, Gil, you misunderstood the results of your experiment.
NASA told Dr. Levin that he misinterpreted his own results.
Yes.
To me, if the results are controversial or unclear, what you want to do is repeat the experiment and gather more evidence to substantiate whether indeed there is evidence for life in the soil. And so I would definitely repeat controversial results to find out what really happens rather than avoid it the way that NASA did since then.
It doesn't mean that it didn't find life, because so much of our perception about Mars has changed since Viking. We also have to remember, at the time, even NASA was almost dismissing Mars completely as just a dry, barren place that less interesting than they were hoping for.
I was, pretty tuned into that as a young man watching those Viking landers. I got an open mind, I think, about those results. I think, it did show a reaction. It seemed like there was, a good potential that could have been something.
There is life on Mars, and they know it, and they don't want anyone to know it because of the Brookings report.
There's life on Mars now?
Yes.
In my opinion, the chances of finding life on Mars is 100%. Gil Levin, during the experiments he flew to Mars on Viking, he found evidence of biology at both landing sites. We now know that life exists on Earth in the most bizarre and strange places, deep in the bottom of the ocean, deep within the crust of the Earth, high in the atmosphere, in the stratosphere. Life seems to be wherever you find water, a source of energy, and those 20 critical biogenic elements coexisting together, there you find life.
Can't we just clear this up? Why didn't they just send another life test experiment to...
Because they don't want to know.
They're not interested in life. They're interested in geology.
Gil Levin's other son, Dr. Henry Levin, earned his PhD in molecular biology from the University of California, Berkeley in 1987. He's now a biologist for the United States government.
We now know there are organic molecules on Mars, and had they been able to detect it back during the Viking era, when I think the leadership was much stronger, there would have been a call to send new experiments, new life detection experiments to Mars.
On Mars, NASA has designated what they call special regions, which is where they expect a higher possibility of finding microbes on the planet due to the higher temperatures and presence of transient liquid water, typically seen when the salt on the planet's surface absorbs water from the atmosphere and releases trickles of it down a slope. Ironically, NASA is purposefully avoiding these special regions for fear of contaminating them with Earth microbes. Dr. Chris McKay, a planetary scientist and astrobiologist for NASA, was quoted as saying, "It seems pointless to send missions to search for life into non-special regions." But as luck would have it, many think this rover image shows an up-close look at water trickling down a nearby slope.
I don't understand why NASA doesn't send experiments for life detection to special regions. It only confirms a lack of interest in discovering life on Mars. They have convinced themselves that there is no existent life on Mars, and so they suspect it would be a waste of funds.
Every lander after Viking was not sterilized, including none of the Soviet landers and none of the European Space Agency.
Really?
NASA said, well, officially it's ambiguous, but they stopped spending the money to sterilize. It was a lot of money because to heat up the whole Viking lander required that all the electronics be specially high temperature resistant electronics, an ordinary spacecraft would be destroyed by the sterilization.
But I think it's been a large part a group think, where they have circled around the idea that there couldn't possibly be life on Mars. And I just don't think that's a logical conclusion.
Professor Richard Hoover and Dr. Ron Levin, along with others, proposed to send an updated life test to Mars, which would also include a video microscope. Elon Musk's SpaceX said they would send it to Mars for free if Hoover and Levin could raise the funds to design and build it. I'm sure they could use some help. So if one assumes microbial life exists on Mars now, what are the chances something more advanced developed on the planet?
It looks completely dry and desert today, but there's no reason that ancient life on Mars couldn't have found its way underground, where it might exist still today, or just simply have been fossilized. If there was microbial life on Mars, it might have evolved to be multicellular and larger, so it's conceivable that in the distant past, Mars had macroscopic life, plants, or even maybe something like animals.
The Opportunity rover took an image of a structure that was very interesting. The picture was sent back. A friend of mine was contacted. Can you identify this? Richard Keyes took a look at it and said, yes, it's a crinoid. He's an authority on crinoids.
I've been collecting crinoids since I was 6 or 7 years old.
Crinoids come in all shapes and sizes, but they mostly look like flowery starfish. Author, published researcher, and expert amateur paleontologist Richard Keyes literally wrote the book on crinoid fossils.
So you can see the Phainocrinus here, Zeocrinides here, the Alchemacrinus, the Eupachycrinus, and in this corner is a Daciocrinus. I've dug up areas to where I've collected 3,000 or 4,000 at a time.
Crinoids are animals. They're not plants, they're animals. They live in the oceans. They've lived in the oceans for hundreds of millions of years. Most of the crinoids that we know from fossil record, but there are also many living crinoids in the oceans today.
It's a wonderful 3D object, and the shadows show its characters, and it does appear to be a crinoid. Since we do not have it in hand, no one can prove it is or it is not a crinoid.
That picture was taken, and within 3 hours of the photograph being taken, the structure was ground into dust. It was destroyed. When I finally talked to David McKay about that, he said, oh yes, people at headquarters told me they were convinced it wasn't a crinoid. I said, well, why? He said, well, that was why they used the rock abrasion tool. I said, what? Well, he said they wanted to grind into it to see if it contained any carbon. I was shocked. David McKay was a geologist. He knew paleontology. He knew that was a nonsense answer. Absolutely. I remarked that's kind of like finding a dinosaur skull and smashing it open with your rock hammer to find out if it contains any brains. What should have happened is they should have immediately stopped everything they were doing and taken photographs from different angles with the best resolution they could get under different lighting conditions. In fact, a week or even a month should have been devoted to that one site instead of within 3 hours grinding it to dust. I realized that when the grinding was done, they had actually ground down through the stem itself, and so we see from the base of the crown, we see the curved stem going down along this way, and then lots of Cirri-type structures here, and then these pairs of what appear to be cirri coming up here and here. That is one of the features of stalk crinoids that live in deep waters.
What's your response to paleontologists saying that the fossil, or what appears to be this fossil, is not differentiated from the matrix?
Oh, well, yes, it is. It is, certainly. You can see that it has a different texture than the surrounding area. We can see evidence here as the arm goes up. you have the bifurcation where the arm splits. And on this, you see it comes up here, and right there is an indication that even though it's broken, that this arm had split. And this is quite common, you see here, and the splitting or the bifurcation of the arms. But also there are these tiny little pustular type structures on the surface of the arm. So there are so many details of this and in this one you can see all of these tiny small plates, very similar to what we're seeing in this area.
I have spoken to this and shown the picture to other paleontologists, told them where it was from, and they have no comment.
The scientists don't really want to argue about this from a scientific point of view. It's dismissed as, well, we know it can't be right because it's on Mars. And in fact, if you show this image to someone without telling them where it is, the general agreement is this is the fossil of a crinoid.
We emailed the photo to a paleontologist at the University of Cincinnati and asked him what he thought. He said, yes, this looks like a fossil, specifically parts of a crinoid or sea lily arms. Where did you get the specimen? We told him the specimen was on Mars and received no response.
The markings that we're looking at here today were made by worm-like creatures 380 million years ago. These are fossilized impressions in the rock that you can see actually descending and moving through the bedding plane of the rock. Trace fossils are the fossilized remains of trails, tracks, and burrows left behind by creatures in the mud.
Barry DiGregorio is an astrobiologist who has authored 3 books on Mars. He spent 10 years as a research associate for the Cardiff Centre of Astrobiology at Cardiff University in Wales. In 2010, DiGregorio was made an honorary research fellow for the Buckingham Centre of Astrobiology in the UK.
In 2017, I was looking at raw images from Curiosity and noticed some images that have never been seen before on Mars. And they look very much like Ordovician trace fossils, worm fossils to me. Since these trace fossils were found in Gale Crater in an ancient lake 3.7 billion years ago, it's possible that ancient worms existed on Mars at that time. We're looking at a very ancient surface on Mars, and the trace fossils that could be there would be of a very ancient variety, possibly 3.7 billion years old.
Whether or not you find this evidence of microscopic or multicellular life convincing, the question is, shouldn't we go take a closer look? Regardless, there's more to the story which we'll present next, but before we do, it's important to understand the following word: isotope. So if you tune in to watch The Simpsons on Sunday night, you might remember the Springfield Isotopes as the local baseball team. But scientifically speaking, you can think of isotopes as atoms with a different number of neutrons in the nucleus. For example, if you add a neutron to a hydrogen atom, you get hydrogen 2. Each element on the periodic table has its isotopic variations, which are studied closely when scientists observe the chemical composition of any given material, including meteorites. The isotopic composition of certain meteorites tell us they came from Mars. They can also reveal more about the history of the planet.
How do we know a meteorite like that is from Mars? How do we know that the Allen Hills meteorite was from Mars? Well, it turns out that we've made measurements of the Martian atmosphere. And when they analyzed these meteorites, those were found to have compositions of gases within little pockets that have the same kind of chemical abundances as the composition of gases in the atmosphere of Mars.
Dr. Richard Hoover.
Yes.
Sharp as a tack.
Yes.
Still to this day.
Talked with him.
He told me a lot about his work on something called the Orgueil meteorite. You published a paper saying that the Orgueil
meteorite
yes,
was not from a comet.
No.
And instead is actually from
It's
Mars.
part of old lake bottom on Mars, from early Mars. It's very old.
Based on what?
In my article, I simply said the isotopics test, that when one finds a rock and says, oh, this may be from Mars, then you test its oxygen isotopes, and if the oxygen isotopes fall on a certain line, then it's from Mars. And the CI are definitely from Mars.
The Martian meteorites share a unique isotopic signature with the current atmosphere of Mars. Recent probes to Mars, of course, have identified argon, neon, and these other chemicals on Mars, and those turn out to be present in the meteorites found on Earth that are believed to be from Mars.
Xenon 129.
Yes.
That sounds made up.
It's not. Xenon is a gas you use in flash bulbs, flash lamps. It has several stable isotopes. The two prominent ones are Xenon 132, that's its atomic weight, and Xenon 129. On Earth, on the Sun, on the planet Jupiter, solar wind, and the meteorites we ground up, those two are 129 and 132 are in balance in Xenon. But on Mars, there's 2.5 times more Xenon 129 than there is Xenon 132. And they can't explain it by any natural process.
So you're saying that so Xenon 129 is produced naturally.
In supernova, yes.
In supernova.
In
But
large amounts.
but you're saying to find an elevated level of Xenon 129
yes,
in a planet's atmosphere can only mean one thing.
It's not good news.
Nothing you can be is more terrible than what I am.
Most people think life is only here, but if we were to discover it elsewhere, and then
I feel like we can learn a lot from anyone that's different from us, or anything that's different from us.
yeah, good point. If we found life up there, what would that tell us about us here on Earth?
I wouldn't be surprised if there is life in a bunch of different planets or celestial bodies.
If we found life there, what would that tell us?
It would be very interesting. Depends on the form of life.
Brian, I think they're just going to find a lot of red rocks out there.
A lot of red rocks. Yeah, that's kind of what they've been finding. But what happens if they pick one up? Look underneath.
What? And that brings up what if there is something under there? What the hell are we going to do? Do we react with war, or do we react with science and we want to find out more about it?
Microbial?
Definitely. Yep.
Anything else?
Maybe some kind of plant life?
Maybe. You think it had water?
Maybe.
Is life up there? I don't know. I've never been.
Don't know what's over there.
Okay, what could be there?
Us. Another
life
like us, yeah.
If we found life on Mars, what do you think that would tell us?
We have to learn their language first.
So we get to Mars, we look under a rock.
So let me ask you this. Have you ever seen a rocket actually took off in front of your eyes to go up in space?
Well, I did, yes, one time.
So you work with the NASA then, that's what you're saying.
Work with the what?
You work with NASA then, that's what you're saying.
Work with NASA? I don't work with NASA, no. Do I look like I work for NASA?
If life is discovered on Mars, it would indicate that there's life in many areas of the universe and demonstrate that there's nothing so special about what we have here on Earth.
If Mars was once wet, and if when it was wet, it gave rise to life, And if that life gave rise to macroscopic multicellular life, like animals, and if those animal-like Martians had developed technology, then in principle, there could be relics of that technology on Mars. Now, that's a very tall tower of ifs.
Professor Jason Wright earned his PhD in astrophysics at UC Berkeley. He now teaches at Penn State.
Because when we look at Mars today, we just see a desert, we see it's lifeless, and we know that it's been that way for hundreds of millions of years. So if there were any kind of life like that, or technology like that on Mars, it must have happened a very long time ago.
Mars was bombarded by asteroids, by rocks, over the past 2 billion years at a level that is more than 20 atomic explosions per square kilometer. And that means that any building would not stay around, it would be demolished. And we need to check more carefully if there is any evidence for infrastructure on Mars or maybe underground that could have survived the impacts. And altogether, I think we should be open-minded to the possibility that the intelligence emerged earlier elsewhere.
Fair warning, the Mars rabbit hole goes much deeper. The following subject matter invites a healthy dose of well-deserved skepticism. Trust me, we get it. No one will blame you for going back to the surface, especially considering the nature of the following high-altitude satellite photographs of Mars that we're about to present. In the original Cosmos television series, Carl Sagan showed NASA photographs that were digitally enhanced by imaging specialist Dr. Mark Carlotto.
Some even think we should go to investigate enigmatic landforms, including one that resembles an enormous human face. Personally, I think this, like hundreds of other blocky mesas there, is sculpted by the high-speed winds. But if we're going anyway, there's no harm in taking a look.
Mark's contributions were critical because they really brought rigorous data. And Mark had a whole career, even before the Mars imaging, of looking at essentially high-altitude imaging on Earth and developing some of the very first algorithms, looking at some of the very first uses of high-altitude digital imaging. And he did this for the government and also in the commercial sector for agriculture. So if anyone is a global expert on high-altitude imaging, it's Mark Carlotto.
I think if we go to Cydonia and we find the face is just a pile of rocks, then I think we have to let this go.
Dr. Mark Carlotto is an aerospace engineer specializing in image processing, pattern recognition, mapping, and machine learning. He received his PhD in electrical engineering from Carnegie Mellon University in 1981, written over 100 scientific papers and 9 books. One of them, titled The Martian Enigmas, was featured in this 1992 television interview hosted by Star Trek's Nichelle Nichols.
And this face, did you think it was an important thing to study?
Others in the mainstream planetary community haven't gotten involved in this, is that it's viewed as being borderline, it's viewed as being outside conventional science, because...
But isn't that the scientist's job, to investigate what is fascinating, what is an enigma?
It is in a perfect world, but some scientists are reluctant to stick their necks out.
We're looking to deep space using high-tech radio telescopes, looking for artificial sources of radio signals,
right,
that we can distinguish from the natural sources of radio signals. Yet here we have our next door neighbor, which shows signs of what some could interpret as archaeological ruins, which requires an entirely different discipline of understanding in interpretation. It doesn't seem like it's treated with the same weight.
Current paradigm now is that intelligent life other than our own exists either far from the Earth or existed in distant time. So long ago in a galaxy far, far away. So anything closer is really regarded with some disdain as being unlikely, not scientific, being pseudoscience or worse. And so that's I think the dilemma we've been in with Mars for many years.
You'll hear NASA and the scientific community say, well, the face. The face is nothing more than a natural feature. It's a hill, it's a mesa. It's nothing more than pareidolia.
Mm-hmm.
Have you heard that plenty of times before?
I think so, about 1,000 times maybe.
Yeah. Pareidolia, the tendency to perceive a specific, often meaningful image in a random or ambiguous visual pattern. Like this. Or this one. Here's another one. It's a cute bear. Maybe even Cookie Monster. But we're not talking about those faces. We're talking about this one.
It's a pretty sophisticated object. What I attempted to do next was say, okay, let's be a little bit more quantitative about it. Is there something that's different about the face vis-a-vis the background? So what we applied was actually a technique that was being developed at the time to detect man-made objects, military vehicles, and imagery. So we developed a fractal model to model the background, and the way it worked is it detects things that are different from the background. So all of these mesas were sort of similar to the background, but the face was different. The face stood out. One of the investigators said it lights up like a 100-watt bulb. It's quantitatively different in terms of a fractal model.
I found it fascinating in your paper, you identified these circles running right down the middle of the face.
And when you start drawing lines through them and constructing ellipses and fitting rectangles, you get repeated expressions of 3, 4, 5 triangles.
If you even take the face out of the equation and just look at the surrounding frame or the platform that it's on, it in and of itself is symmetrical.
Very symmetrical.
And then you start layering on the ellipses, which identify this near perfect, like semicircle at the bottom. It identifies where the top of the head is, and on top of that, these 3, 4, 5 triangles. I mean, like, okay, so 3, 4, 5. Someone might say, what's the big deal?
That's probably the simplest triangle we learn about when we're taking geometry, when we're learning the Pythagorean theorem. It was these repeated examples. It's like, that's why it seemed like it was part of some kind of motif, some element of the design or architecture of it, as an deliberately executed object, as opposed to just an accident.
Why would there be a face? How could there be a face?
Why would the Sphinx be carved? People like to carve faces.
Couldn't Mother Nature sculpt something like that and, it just happens to look like a face?
I've never seen anything like that produced by nature. Have you?
What about the face on Mars makes you think it is artificial in origin?
Oh, it's symmetrical, and it has what looks like a face wearing a helmet. Dr. Carlotto has found. And when we showed these things at a scientific conference, a NASA scientist attacked one of our presenters.
Attacked?
Yes.
Verbally?
No, physically. He said, "I'll deck you." By God, he raised his fist to punch him, and I got in the way, and I told him, "Please calm down, sir."
You guys are having fist fights at scientific conferences?
Well, my friend Vincent Petro said, "You should have let him hit me, John." Then I could have sued his ass.
I thought scientists are all nice with one another.
Well,
they don't fight each other.
I've been a scientist for 40 years, and real science is like professional basketball. It's not supposed to be a contact sport, but under the net in a championship game, tight score, the knees and the elbows, they fly.
Let's talk about this other little feature close to the face.
Yes, the pyramid. It's clearly seen in the Viking pictures.
Well, some people might say, well, you know what, that looks like a mountain or a volcano.
A good geologist can look at the pyramids of Giza and the Sphinx and say, oh, these are all geologic features. I can figure out how to make these with just pure geology. That's nonsense, of course, especially He'll say that especially if there's a rhetorical gun at his head saying you won't get any more grant money unless you say this.
But it's over a mile big.
Yes, it's about 3 miles on each side. It's 5-sided, not 4-sided, like on Earth.
That's so strange.
Others started looking at the data more carefully, in particular DiPietro and Molinar, hence the name D&M Pyramid.
When people think pyramid, they think Egypt. 4 sides, square. This is not like that.
So what's weird about the D&M is it's not 4-sided, it's 5-sided. And when you break down the angles, you have repeated expressions of 30, 60, and 90 degrees. It's also very symmetrical. Something that's 5-sided, you kind of have to pick the right axis of symmetry. And when you do, it's remarkable how symmetrical the D&M pyramid is along that axis. And that axis is actually almost exactly aligned in the same direction as the face.
Does nature do stuff like that?
When you have 10, 20 bits of information that's independent, the way it adds up or actually multiplies out is you get probabilities that are, easily 1 in a million or less that it is a natural object. That nature would conspire in so many ways, in so many different ways, for multiple objects for it to be an accident.
The D&M pyramid certainly has a peculiar shape. Perhaps it's just coincidence, but from high altitude, one could argue there's a similar feature near Washington, D.C. The face on Mars was originally discovered by the late Dr. Tobias Owen in 1976 while working as part of NASA's imaging team. Since then, an often maligned community of independent researchers from around the world have found a variety of interesting surface features taken from satellite images. This is Gary Legier. To some, he's known as the Mad Martian, a self-prescribed moniker attributed to his often brash and provocative online persona. His website looks like it was made in 1998, and by his own admission, it is what it is.
Should I go wipe this off? This is Angel. Tumbleweeds came in again. They were cleaned last week, but everything's back. She's a beautiful girl. I love them all, but I have to compartmentalize them before I let them run around, take turns, because if not, there'll be blood and guts.
There's more to Gary than meets the eye. In 2013, he saved his neighbors from a house fire. He spends his days working as a certified caretaker for his wife and looking after their 12 dogs, chickens, and ducks.
I said, Carrie, it's not a real word, just like supercalifragilisticexpialidocious is not a real word. Okay? Yes, it's a word, but it's a made-up word.
Wait a minute. It ain't a real, I thought it was. I had that debate years ago.
Supercalifragilistic?
Expialidocious. It means something.
What?
Mm-hmm.
Oh.
It means something.
What does it mean?
I forget. It's been that long, it's been years, but I got lost a bet over it.
Are you serious?
Mm-hmm.
But at night...
At nights, I go to Mars. I take off and I get off this damn planet. There it is. That's one of the ones. That look familiar?
Scattered across the surface of Mars, Gary has found a series of similar triangular features, ranging from a half mile to 1.5 miles long. Some have lines underneath. He also found lines elsewhere, each near a crater or large mound. The question is, what natural process could be responsible for making these formations? By no means are we interpreting the image you'll see next as anything more than an interesting surface feature
worthy of closer inspection. One could argue it would make for an excellent tourist attraction. If any entrepreneurs are watching, consider the interest in flying over this. It was originally discovered by a man named Will Faust in 2002, who is now deceased, but the legacy of his discovery is still carried on to this day.
After 3 or 4 weeks of looking at this picture, it dawned on me that I have to get someone to look at this. My wife's a veterinarian, so she would be a great candidate to look at this. Unfortunately, in my house, I'm not allowed to mention the M word.
Independent Mars researcher, author, and artist George Haas and his wife, Dr. Joy Cole, a veterinarian, live on a nice farm where they care for their goats and horses. Together, they've identified some novel data on this structure.
She goes, "Oh, what, this Mars?" I said, "Yeah, this is a parrot on Mars. What do you think?" So she's looking at it and she says, "My God, that certainly does look like a parrot." And I was only looking at the head, the body, the tails, and the little heads, some feet you can see. But she was pointing out all these other anatomical features that were in the formation, and she started to really get intrigued with it, which I was like, oh, we got something here.
So George brings this image to me on his laptop, and I'm looking at it. I'm going, that's interesting. It looks like a parrot, and it's on Mars. So I'm looking at it, and it's got more than just head, body, tail. There are over 20 points of anatomical correctness within this structure.
After that, we decided I need to make a science paper out of this and get some people together. My co-author's a geomorphologist, my wife's a veterinarian, my other friend Jim Miller is an image analyst, so we could probably get a paper put together.
And he did, with a geologist, a geomorphologist, an imaging expert, and 3 veterinarians. The paper was published originally in 2010 in the Journal of Scientific Exploration, and later updated in 2022. The paper demonstrated 23 points of anatomical correctness in this avian-like feature. This next feature was discovered by independent researcher Greg Orm. Dr. Alfred McEwen of Arizona State University says, maybe this feature was lifted up by the faulting. Maybe the surrounding terrain has been eroded over billions of years, or both. Yeah, maybe. What we find most interesting is that it looks an awful lot like the ancient Kofun tombs found in Japan. Certainly worthy of a closer look. So the good news is NASA has been taking a closer look at the surface since the original Viking landers in 1976. And 2 decades later, they started sending rovers. Cliff, I hear you're a big fan of those rovers.
I'm not.
Cliff Dunning is the host of the Earth Ancients podcast, where he and his guests discuss ancient civilizations and the thousands of anomalous archaeological discoveries associated with them.
They're purposely picking the most remote and desolate areas to land these things, these rovers. It's hard to understand why they would not find and land a rover in Cydonia, a place we've known about for decades. Why don't we put a rover down there where we know there's some very odd things? Well, that's going to cause a lot of questions. John Brandenburg made a very important statement when I interviewed him recently and said that JPL doesn't want to find evidence of a civilization because then the manned flights would get activated. They would lose their funding. Who wants a rover when we have boots on the ground? So that's a huge issue for JPL. And that's a likely scenario is that if we do find civilizations there, they're going to lose all their money.
The rover images reveal a desolate and mostly uninteresting landscape at first glance. But upon closer inspection, some peculiar shapes start to emerge. Unfortunately, most of these shapes are far away from the camera and present poorly when zooming into them. Here's an example of a rover image we commonly see. Rocks and debris scattered amongst a desert landscape. But zooming in, we find this strange rock.
Are these rocks? Or something else? What are we looking at here? Even from a distance, one could spot really strange rock formations. An independent researcher, an image specialist from Israel named Rami Bar Alan, takes rover images like this, zooms in on something that catches his eye, and enhances the resolution to produce this. Now, what do you think? How about this one? What does that look like? Let's see, 24, 25. What's that one? Well, that one. Shouldn't we take a closer look at something like this? Or this? Or any of these? So if you were in charge of a Mars rover, wouldn't you want to get a closer look at some of these funny looking rocks? NASA might say they don't want the rovers to get stuck on a rocky landscape, but aren't these rovers designed to literally drive over rocks? Wouldn't it be nice to get a closer look? Do Mars rocks really form into these strange shapes? Or are they something more?
This rock really caught my eye because not only is it geometric in form, it also has more than one axis of symmetry about it. And that, to me, was the perfect object to reverse engineer into a 3D model.
Tim Saunders studied transportation industrial design at Coventry University and currently runs an independent studio designing mega yachts.
It not only caught my eye, but it also caught NASA's eye, because otherwise I guess they wouldn't have gone back and taken more photographs some 10 days later. And in this particular case, there are 3 images of the same object taken at different times, even on different days. So that provides different lighting, different shadows, which really accentuates the sculpture and makes it far easier for me to reverse engineer into something which is tangible on a 3D model. Going back to my university days in engineering lessons, which seem to go on forever, the technical side is there. Now, that's not my preferred way of reverse engineering something, but it's very necessary. What it has taught me from the very beginning is whatever I sketch, I need to know that I can build it. And otherwise, I'm just, playing with lines and shapes. And during my examination, sure, the first thing I'm asking is, how could this thing be made? Is it a natural formation? Does it show signs of machinery? Does it show geometry? Does it show symmetry? Is there an axis of symmetry about it? And in this particular case, this particular object ticks all the boxes for me. I'm fairly convinced it is not a natural rock. The shiny mercury or quicksilver finish is a flight of fancy. That's absolutely true. Let's be honest that most castings, most manufactured objects do have a sheen, but I'm suggesting already that it could be made of metal or an alloy, let's say an alloy of some type. What we're seeing in the photographs taken by Curiosity is something which is, in my opinion, highly corroded. And not only is that due to the minerals and the elements on Mars itself, but also, I believe, highly influenced by the gas in the atmosphere on Mars. What's very different about the atmosphere on Mars is there is something in the order of 98% carbon dioxide. So one of the things that I wanted to investigate on Earth is to see how metal or alloys age and corrode in a high carbon dioxide environment. And it didn't take very long to find various examples through drilling, piping, drilling pumps, drilling equipment, where carbon dioxide is very, very prolific. And strangely enough, the same colors, that sort of oxidized red-brown rust color comes out very, very clearly. And not only the color, but also the way that the material seems to disintegrate and crumble. it sort of seems to flake off in sort of large pieces, which in my opinion really, again, validated how a piece of metal, an alloy, may corrode on Mars. Now, this is all pure speculation. However, I cannot ignore the similarities.
NASA has been instrumental in deepening our understanding of the solar system, our galaxy, and the universe. Unfortunately, as it relates to the controversial subject of extraterrestrial intelligence, some question their transparency. What is the Brookings Report?
The Brookings Report was part of the founding charter for NASA, and it discussed the possibility that signs of intelligent life would be found on the moon or Mars, artifacts, they called them. And they said, if you find those, suppress them.
That sounds like X-Files.
It was written a long time before X-Files was written.
While the Brookings Report doesn't specifically direct NASA to suppress evidence of extraterrestrial artifacts if they were found, it does recommend NASA pay close attention to what the public's feelings would be upon disclosing the information. It also questions whether or not that information should be withheld. Quoting from the Brookings Report, it is conceivable that there is semi-intelligent life in some part of our solar system. Artifacts left at some point in time by these life forms might possibly be discovered through our space activities on the Moon, Mars, or Venus. With regard to the public, the Brookings Institution goes on to recommend that NASA continue studies to determine emotional and intellectual understanding and attitudes and successive alterations of them, and how might such information, under what circumstances, be presented to or withheld from the public, for what ends.
Do you think NASA's still running that playbook?
Yes.
Why?
They were worried about national morale.
What do they think, we can't handle it?
Knowledge is power.
It was a real study done by the Brookings Institution. It was a real report, you can get it, to assess the potential impact of the phenomenon on the country, on what people would think about it, how they would react, for fear of just upsetting the public.
The report reminds NASA that anthropological files contain many examples of societies, sure of their place in the universe, which have disintegrated when they have had to associate with previously unfamiliar societies.
I think their intentions were good. I don't know the extent to which its recommendations have been executed or institutionalized within government agencies, but there's some evidence that it has been.
There's millions of people who are looking forward to this. Yes, they'll be afraid. Yes, they'd be uncomfortable for a bit, but to know that we are not alone in the universe is, number one, it's a big deal. Number two, we begin to evolve when we know we're not the only ones, because then it's like, where did we come from?
Arthur C. Clarke said it very well. Either we're alone or there are others around us, and either is terrifying. And I think that's really what this is all about. If we go there and we find that no one has ever been there, it might be very good evidence that we're alone. The other hand, if we go there and we find some interesting, intriguing remnants, artifacts, we may have definite proof that we aren't alone. However, the whole issue is whether we're alone or not. If we go to Cydonia or other areas of interest on Mars, we may find nothing. On the other hand, we might find everything.
On Mars, we have rovers, we have orbiting satellites that are continually imaging the surface of the planet. And it's just by luck that we have some scientists, we have some image specialists who are saying, look, we got something here. And they've known about it for 30 plus years. So this is a big problem. And I think it's time that we, quit hiding this information and begin releasing it to the public, because we're ready. I speak to people all the time. We are ready for disclosure.
One of the biggest mysteries about Mars is what happened to its atmosphere. Today, relative to Earth, it's virtually non-existent. Scientists agree that Mars used to have a lot of liquid water on its surface, including oceans, lakes, and rivers. But the problem is you can't have any of those without an atmosphere, like the one we have here on Earth. This suggests that the Mars atmosphere used to be a lot like ours, including a lot more oxygen. We know this because of the planet's signature color. Why is Mars red?
Mars is covered with red Georgia clay.
So Mars is red because it's just rusted all over.
Yes, it's rust.
Rust is the common name for iron oxide, which occurs when iron is exposed to water and oxygen within a planet's atmosphere. Unfortunately, the atmosphere of Mars has mostly disappeared, leaving many to wonder how exactly. The commonly accepted hypothesis is that the atmosphere was stripped away by the solar wind after the disappearance of the planet's magnetic field.
We have evidence that Mars once had a magnetic field. And this is part of this whole story about Mars, that it started out with a thicker atmosphere, a core that was creating a magnetic field, and gradually the atmosphere escaped and the planet cooled off and that magnetic field went away.
Earth has a strong magnetic field, which does protect us from the sun's solar radiation. The fact that the magnetic field on Mars is so weak certainly doesn't help the planet retain its atmosphere, but the weak magnetic field alone might not fully explain the nearly complete loss of the atmosphere. Some say the solar wind could not have exclusively been responsible for stripping the planet of the atmosphere. There's compelling evidence suggesting that it was something else entirely. We're going to present two fields of study that have yet to be taken seriously by the scientific community. To help us explain the first, here's a beautiful photo of the Grand Canyon in Arizona. Remember this because we'll come back to it in just a moment.
The role of massive thunderbolts or plasma is generally overlooked.
Ev Cochran has a master's degree in genetics and has authored many books on comparative mythology. He's a longtime collaborator of David Talbot and Wallace Thornhill, the founders of the Thunderbolts Project, a group of scientists who study the role of electromagnetism in the universe.
Our hypothesis holds that electromagnetic forces dominated during a recent period in Earth history. And the same conclusion derives from the fact that Mars's surface has been totally ravaged by catastrophes from top to bottom.
In 2014, the Thunderbolts Project produced a documentary narrated by founder David Talbot, explaining how the surface of Mars was scarred not just by meteor impacts, but by electrical discharge.
As a discharge column sputters across a surface, its diameter will vary with discharge energy and a narrowing or pinching by the induced magnetic field. The pinching effect will be most strongly focused at the point of contact with the surface. The sputtering arc will leave a unique signature in the form of scalloped walls.
Electrical discharge is simply the movement of electrical charge from one place to another. It's just that simple.
Dr. Don Scott, another contributor to the Thunderbolts Project, earned his PhD in electrical engineering in 1968 and was a professor in the Department of Electrical and Computer Engineering, University of Massachusetts Amherst, for 39 years.
If you walk across the rug on a winter's day and scuff your feet, you're liable to pick up electrons from the rug into your body, and then when you reach out toward a doorknob, those electrons are looking for ground. They jump the gap to the doorknob, and you see the spark, and you feel it. Another one, more dramatic than that, is in the sky. What is a thunderstorm? It's what is lightning. Lightning is the accumulation of charge in a cloud, discharging to Earth, looking for ground, and of course you can see it and hear it, and if you're not lucky, you will feel it.
What you're seeing here is artwork made by a company known as Captured Lightning. They discharge electricity into acrylic, creating a beautiful design known as a Lichtenberg pattern, and sell these sculptures on their website. Another company, Cadvica Engineering, uses electrical discharge to make Lichtenberg patterns in their furniture. The lightning we see in the sky can produce these same Lichtenberg patterns outside on the ground, and on some unlucky people. An important question raised by the Thunderbolts Project is whether the Grand Canyon was also created by electrical discharge. When viewed from high altitude, it arguably resembles the same Lichtenberg pattern.
We also know from plasma physics, and this is very well documented now, that plasma and electrical phenomena of this nature can be scalable. So you can scale it up from essentially the microscopic scale, literally from the microscopic scale, up to planetary scale and even solar system scale. The same phenomena occur at all these various scales.
Since electrical discharge is scalable, is it possible that a planet-sized lightning bolt caused this? We'll come back to Arizona in just a minute, but for now, consider Valles Marineris on Mars. NASA refers to it as the Grand Canyon of Mars, and it's the biggest canyon in the solar system, about the size of the United States. As with the Grand Canyon on Earth, geologists have yet to offer a comprehensive explanation to its formation. It has such a distinctive shape, and in 2015, it was reproduced in a laboratory by experimentalist Billy Yelverton. Yelverton has demonstrated a variety of ways that electrical discharge can physically alter soil and sand.
When we look at the surface of Mars, we see craters. And I want to be very specific that we see craters. People assume that they're meteoritic impacts or asteroid impacts or some kind of physical impactor. That's an assumption in many cases. We don't know for certain. And I say that as a geologist who's also interested in the history of his field, geology. So we have craters on Earth. And in the past, there were incredible controversies as to how some of these craters were formed.
Sometimes electrical discharge can produce craters. Watch this. Did you see that? A lightning bolt struck a gas station parking lot and made a small crater. One could argue that an up-close look at the debris looks a lot like the rocky terrain we see from rover images. Electrical craters can also look a little different. Dr. Scott explains.
Electrical craters most often, not always, but very often, create a sort of a hexagonal pattern in various places on the base of the crater, or even the crater shape itself can be hexagonal. If that happens, it's a strong hint that it was an electrical phenomenon.
This is a typical impact crater, circular in shape with a surrounding debris field. But this is an electrical discharge crater, hexagonal in shape with no surrounding debris field.
When you have craters on Mars that have little craters around the edge, how do you explain that? Did the big meteorite decide to land one place and then all the little meteorites afterwards decide to land just on the edge and nowhere else? It seems a little silly. It seems a little coincidental.
Back in Arizona, a hop, skip, and a jump away from the Grand Canyon is Barringer Crater, also known more commonly as Meteor Crater. Despite its common name, according to the Barringer Space Museum's pamphlet, no meteorite was ever found because they say it was totally disintegrated. According to the staff, the meteor fragment they have on display in the museum wasn't even found at the site. The exhibits at the museum also claim that no meteorite was ever found. As you can see, it's also hexagonal. Regardless, what could explain electrical discharge on a planetary scale?
So there's reason to think that a neighboring planetary body was the focus of an intense planetary discharge.
My research is consistent with the idea that planets have both mass and charge. And if they're far enough apart, they don't really see each other electrically, but if they get close enough together, they do. And there can be discharges, electric discharges between planets that are horrendously strong and can have cataclysmic effects on each other.
The telltale signs of major catastrophe are everywhere in evidence.
Imagine if two planetary bodies of opposite charges passed by one another in an early, unstable version of the solar system. Is it possible that something like this caused the massive Valles Marineris scar and countless craters we see on Mars today? Some think so. Others think our sun could have been responsible.
There's this popular, I'll call it a myth in a way, or a popular image among the general public that the sun is fairly stable, fairly regular. It just rises in the east, sets in the west on a regular basis. We don't need to worry about, we don't need to think about it. But in fact, the sun is very turbulent. It's very volatile.
Professor Robert Schoch earned his PhD in geology and geophysics from Yale University in 1983. He's now an associate professor of natural sciences and mathematics at Boston University.
So if you were on Mars when a major solar outburst occurred, which is what I think would cause these major plasma discharges, you would see probably what would look like huge lightning bolts hitting the surface, literally causing craters or strings of craters. I mean, they'd be very, very bright, the discharges, and it would essentially burn the rock and spew rock all over the place. And you'd probably have series where it hit and then hit again, or just sort of cut like a rotor going across an electric rotor, but plasma discharges. It'd be incredible. It'd be very exciting to me as a geologist to be able to witness something like that. And you would have all kinds of shock waves coming from it, throwing matter into space. My point is that Mars as a planet has experienced, in my assessment, a whole series of solar outbursts and electrical discharges which did nothing but erode away the atmosphere. I shouldn't say it this way, but I'll say it this way. It's surprising Mars has the atmosphere, the little bit of atmosphere it still has. It's so vulnerable.
Given the evidence supporting a geological catastrophe, did electrical or plasma discharge also play a role in the loss of the atmosphere and the eventual death of the planet? Perhaps. Regardless, there's a second field of study that offers yet another explanation for the loss of the planet's atmosphere, one we're presenting throughout this film. So you said there's radioactive hot spots.
Two prominent ones.
On the surface of Mars.
They're in the north of Mars. One is near Cydonia Mensa, also in a place called Utopia, which is another location of some strange looking landforms. And it is a place where there's elevated levels of radioactive potassium from neutron bombardment and also thorium. And it also turned part of Mars' surface into glass, trinitite, like at the Trinity test site. Then there's at a place down in the south of Mars, there's what's called the antipode of the hotspots. And that also has a hotspot. It means a shock wave wrapped itself all the way around the planet Mars and collided with itself on the far side. We have evidence of a massive shock wave that basically drove much of Mars' atmosphere at that time out into space. raised on Star Trek and the moon race. But after I'd done the work on Mars, I discovered these equations. I found, because of I'm a plasma physicist, there's a plasma effect called an E cross B drift. And if you put two parallel plates at different voltages and a magnetic field coming out of the board, every particle you release, protons, electrons, positive, minus, heavy, light, doesn't matter, they'll all end up moving at the same speed in the same direction.
Wait for it.
Now, if you tilt the plates so the electric field is stronger near the bottom than it is near the top, the particles will all accelerate, just like in a gravity field. And this ultimately leads to this equation, which is the metric tensor of Einstein's gravity theory. And this is the Faraday tensor of relativistic E&M. We can make gravity with electromagnetism.
This is Dr. John Brandenburg. He's currently senior scientist at Kepler Aerospace in Midland, Texas. He earned his PhD in theoretical plasma physics at the UC Davis and Lawrence Livermore National Laboratory in Livermore, California. In the early 1990s, he worked on NASA's Clementine mission, a space probe that was sent to map the moon. Clementine also detected enough water in the polar craters to support a human colony and a rocket fueling station. He was a part-time instructor of astronomy, physics, and mathematics at Madison College, Wisconsin, and most recently at Cal State Fullerton. He holds 8 patents, including one for an electric rocket engine called the Microwave Electrothermal Thruster. It uses microwaves to heat water into a plasma state for propellant, which is then exhausted as water vapor for thrust. Today, you can find one of these thrusters currently up in use up in outer space. He also developed something called the Colliding Microtori experiment for NASA, which is a fancy way of saying he developed a nuclear fusion experiment. When he was 11 years old, he asked his father what he should do when he grew up. His father suggested, as fathers typically do, that he work on unifying gravity with electromagnetism. So he did, and he came up with a theory that says you can
make gravity with electromagnetism?
Yes, we can modify gravity fields.
Modify?
We can add or subtract gravity from the gravity that naturally exists using electromagnetism. And this theory says that that's possible, called the GEM theory. I got the best formula for big G that exists in physics.
In a video that Dr. Brandenburg shared with us, you can see a small piece of metal suspended in the air by a balloon at a frame. When electric current is run through it, the metal loses weight and is lifted slightly higher by the balloon. When the electricity is turned off, it gains weight and lowers back down. The Defense Advanced Research Projects Agency, otherwise known as DARPA, took notice of this video and funded Kepler Aerospace to develop the theoretical model of gravity modification even further. Dr. Brandenburg's GEM theory has been published in scientific journals. In 1987, Dr. Brandenburg was the first to publish his other theory on Mars once having an ocean. Most scientists rejected the idea at the time, but it's commonly accepted today. He speaks of his love for Star Trek often, and nowadays he's permanently attached to a
LVAD unit?
Yes.
That does, what's its purpose?
It assists the heart. I can tell people are paying attention because they get mad at me. So that's what I thought I would do with my scientific career. Not go investigating strange things on Mars.
And the strangest of all has to do with his research into the elevated levels of xenon-129 in the atmosphere of Mars and the radioactive hotspots on its surface. We'll come back to that soon, but for now, let's get the obvious question out of the way.
You have indicated that Mars was totally different thousands of years ago. Is it possible that there was a civilization on Mars thousands of years ago? Would you rule that out? That, see, there's some people, well, anyway.
I would say
that is extremely unlikely.
I think the scientific community and NASA are being very cautious about their beliefs of what's on the surface of Mars. I think they're concerned about if they make a statement that just takes it a little too far, that they will lose their credibility and their funding from Congress, perhaps. So, yeah, I think they need to be willing to risk, and I think they need to consider Cydonia as a landing site for future Mars rovers.
If they disclose this, the cat's out of the bag, then we are not alone in our universe. And that's an issue for them. You would think that they would be very much open to it. And I interview a lot of people, and I know on social media, we have thousands, millions of people who want to know we're not the only ones in the planet, the only ones in the cosmos.
I think the possibility of intelligent life elsewhere is threatening. And I think perhaps that's and that's why we've had, so many thought experiments. That's why we have science fiction. We're wrestling with that possibility, and we're putting ourselves into those situations. And sometimes we're finding the trouble with tribbles, and sometimes we're finding Battlestar Galactica. So we're wrestling with that, and we're wrestling really with our own future as a species.
Dr. Randy Pozos earned his PhD in social cultural anthropology and a master's degree in public health from UC Berkeley. He's an ordained Catholic deacon and one hell of a nice guy.
I think in that regard, I maybe go back to Carl Sagan, in Cosmos, who pointed out, there are these, pyramids, right?
One of the strangest features on Mars, the pyramids of Elysium, 10 times taller than the pyramids of Egypt. Perhaps they're only mountains sculpted by the fierce winds, but perhaps there's something else.
Here are some recent images of pyramidal features on Mars.
So we go and we find these pyramidal shapes, and perhaps they are just the products of a natural process on Mars. But we won't really know that unless we know the history of Mars well. And if there is evidence of a lost civilization, and it's anything like ours, it will take advantage of natural landforms to live and to grow. Potentially, we might find more remains of an intelligent civilization on Mars below the surface.
What we were taught and known is that, or thought that we were the greatest thing in the universe, most advanced and nothing else out there. So the scary part is not even if they're there or not, it's the unknown. If the president was to come on tomorrow night on TV and announce to the world that they have discovered life on Mars, it's going to send a shockwave throughout humanity. People are going to be excited, from people who are having fear excitement or the excitement of wanting to go. And I believe the demand of wanting to go is going to outweigh the fear. The fear has to be overcome. It's called grow some nuts. You know what I mean? People fear when they go on the battlefield knowing they're going to die. We don't know that we'll face certain death by going to Mars. We don't even know if anyone's home or not. And even if they are, we don't know what that would preclude anything malevolent or benevolent upon us, but we will face it, and we have to.
The human species came to Earth only over the past few million years. That's one part in 10,000 of the age of the universe. And so there could have been a lot of history before us that we are not aware of. And as much as we want to believe that we are the pinnacle of creation, I don't think so.
Professor Avi Loeb received his PhD in plasma physics from the Hebrew University of Jerusalem in 1986. He's currently a professor of science at Harvard University, a New York Times best-selling author, and leads the Galileo Project, searching for evidence of extraterrestrial technological artifacts.
If you come late to a play, just at the end of the play, and you're not at the center of stage, the play is not about you. and you better find other actors who know what the play is about. And that is the reason that I'm open-minded to learning from neighbors that we might have on the cosmic street.
Undoubtedly, there's a growing public interest in sending humans to Mars. We often think of it as the next frontier of exploration. But what we find so incredibly interesting is that in the early 1970s, the CIA and the United States Army took a specific interest in Mars. No one will blame you if you find what we're about to tell you a bit woo-woo, as the kids say these days, but regardless of what your opinion might be of their investigative tactics, the fact remains that from 1977 to 1995, the United States Army ran a psychic spying program, otherwise known as remote viewing. One of the original officers was Joe McMoneagle, now a retired Army Chief Warrant Officer.
The original protocol started out very early on. It started out way back in the very early 1970s, around 1972, with the original CIA interest. They hired SRI to check it out, and SRI labeled something they didn't understand, remote viewing, because they didn't have a good word for it. They didn't want to alarm everybody with what's this thing we're calling psychic something or other. They said that raises a lot of very ugly emotions, so we're going to call it remote seeing or remote viewing.
When Joe remote viewed, he was tasked against Mars 1 million BC.
In the year 2000, the CIA declassified a transcript from one of Joe McMoneagle's remote viewing sessions in 1984. Each session had two people, a subject and a monitor. The session began with a sealed envelope coupled with geographic coordinates. Officer McMoneagle, the subject, did not look at the information inside, which read, the planet Mars, time of interest, approximately 1 million years BC. He spoke aloud to his monitor, saying, I'm looking at an after effect of a major geologic problem. His monitor directs him to go back to the time before the geologic problem. McMoneagle continues and says that he sees large, flat surfaces, very smooth, angles, walls, really large, megalithic, pyramids. They're huge. They're like shelters from storms.
We had no idea at the time. In fact, I didn't know personally until about 30 years later when I was reading a book where Joe talked about it. And I got pretty excited then because what Joe had recounted in his book was very, very similar to what I and the other members of Ingo Swann's team had reported.
This is Army Intelligence Officer Tom McNear, a lieutenant colonel, now retired. He was recruited into the Army's counterintelligence and counter-espionage program for 22 years, and a member of the Army's remote viewing program from 1981 to 1985. After that, he worked as an Army civilian intelligence officer for 23 years. He never worked with Joe McMoneagle, but decades later realized a number of similarities between their remote viewing sessions, including the odd feature known as Crater Pyramid.
I do believe Crater Pyramid was one of them that he was tasked against, and Crater Pyramid was the one that I was tasked against as well.
Now, what's really interesting about this particular pyramid, you notice it's sitting on the side of the impact crater. And that's a real trick, because that means the pyramid had to be put there after the impact crater. Because if the impact crater hit after the pyramid was there, it would have destroyed the pyramid.
So I was a member of Ingo Swann's 5-person remote viewing team that on 15 June 1984 remote viewed Mars. We all reported common things in the environment, temperatures, textures, smells. We reported man-made, and we struggled with them being man-made because we knew we were on Mars, but artificial, not natural formations, pyramid structures. And then many of us encountered entities, and we struggled with how to call them entities, whether they were people or whether they were beings of Well, even today I struggle with how do I describe it.
McMonagle described what he viewed in his session, telling his monitor that they're very tall, very large. They're ancient people, dying, past their time or age. They're looking for a way to survive and they just can't. His monitor asked, what is it they're waiting for? McMonagle answers, a group or a party of them that went to find a new place to live due to the corruption of their environment. It's failing very rapidly, and this group went somewhere, like a long way, to find another place to live. It doesn't matter if you take remote viewing seriously. Again, the fact is, our military had a specific interest in Mars. The question is why? We don't know for certain, but the evidence Dr. John Brandenburg presents on Xenon 129 and the radioactive hotspots might give us a clue. You chose not to report this to NASA, but to the Pentagon.
Yes.
Most people think that the government, especially the military, want to keep things under wraps. They don't want stuff like this coming out.
This is different, a different case. We're talking about a different planet. What happened on Mars apparently happened long before there were dinosaurs, put the planet in deep freeze to preserve it.
The Pentagon told you to publish this research?
Yes. It's their job. I'm doing my job. They're doing theirs.
Nothing you could be is more terrible than what I am.
You discovered what you call an R-process event.
Yes.
In Mars's ancient past.
Yes.
What's an R-process event?
R-process is the physics that happens at a massive thermonuclear weapon.
So you're saying a nuclear weapon was detonated on Mars?
Yes. The explosion was massive. It was 10 to 100 times more violent than the impact which destroyed the dinosaurs on Earth. It's difficult to digest.
So right now, perhaps Mars is not recognizable as the wonderful blue orb that we see from space. But looking there, looking closely, we may find essentially a time when it looked very much like Earth. We may also find, in looking at Mars today, what our planet might be like in the future if there's the same disaster that occurs here.
We invited representatives from NASA to participate in an on-camera interview with us about everything you've seen in this film. Our repeated requests for interviews went unanswered. We then contacted Jet Propulsion Laboratories' media department for comment and received the following reply. JPL will be unable to support you because you have no distribution secured. We reached out to NATO's Nuclear Planning Group regarding Dr. Brandenburg's discovery and received no response. We asked his alma mater, Lawrence Livermore National Laboratory, to participate, and they said, unfortunately, we will decline your invitation to participate in the documentary. We invited a nuclear weapons expert from Georgia Tech to interview, but they also declined. The history of our solar system might be different from what we expect, which understandably makes some people uncomfortable. The question is, what do we do now?
I truly think that sending humans to Mars has the ability and the potential to unite us as humans.
Janet Ivy Dunsing is president of Explore Mars, a nonprofit space advocacy organization that was created to advance the goal of sending humans to Mars by the mid-2030s. She's been awarded 12 regional Emmys and 5 Gracie Allen Awards for her children's series, Janet's Planet, that airs on more than 140 public broadcasting stations nationwide.
Watching people from all walks of life, a global team, go, have a shared experience, put their boot prints on the red planet, all at the same time, sends a message for all of us back here at Earth. If they can go in unity, have a shared experience, consider the mission more critical than any of their own personal agendas, that message to us good humans here on Spaceship Earth should be the call to action to be better crewmates here as they are being better crewmates there.
So we have a joke in the Mars community. It's like we're always 20 years away. For the last 40 years, I think we've been 20 years away.
It'll be great if we could get humans to the surface in 2033 or 2035, but even if we can't, there are so many other things we can do to advance the overall goal of getting humans on the surface later in the decade.
Chris Carberry is the CEO and co-founder of Explore Mars. He's authored 2 books titled Alcohol in Space and The Music of Space. He earned his master's degree in history and archival methods. Joe Cassidy is executive vice president of Explore Mars and holds 4 patents for electric propulsion technologies. He earned his master's degree in aeronautics and astronautics from Purdue University in 1983.
In the 2030s, there are a lot of good opportunities to go to Mars. There's some favorable alignments between Earth and Mars that make it easier to get there. And I think that's what Explore Mars as a group, we've been very focused on that, to say, let's look at those and see what needs to be done, make sure we're getting ourselves ready to take advantage of those opportunities to maybe make that leap in the 2030s.
Well, if it's Elon Musk, he's trying to put a civilization on Mars, but I don't think it's going to be that easy because so much of the planet is in decay.
We make movies about going to Mars and what it would be like to live there, but it's really exciting to have something like Starship actually finally look like it could make that a reality for us.
So let's just talk about SpaceX.
SpaceX desperately needs to know, is there any biology on Mars today? And if there is biology, is it harmful to humans? This is crucial before you send astronauts to Mars. It's what's called due diligence.
If we send humans to Mars, it would be important to first know whether there is a microbiology that might endanger the astronauts that we place on the surface.
The current Mars sample return mission envisioned by NASA and the European Space Agency is dangerous because they could be bringing back pathogenic organisms from Mars that could be introduced to the biosphere.
The whole idea of planetary protection, which is what you're referring to, there's both the danger that something that's a Mars organism could get carried back to Earth and is something we're not exposed to at all. You know, we just went through the pandemic, so we know what can happen if you get a new kind of virus or microbe that could be potentially dangerous. So we definitely want to protect against that. But then there's also the forward part of planetary protection, which is we all have our own, you know, little biomes that we carry with us, and our machines carry organisms with them. So we want to be careful that we protect Mars against our organisms that could, you know, in a different environment like Mars, maybe, you know, take over, be an invasive species of a kind, or also confuse our instruments so that we would think we were looking at life on Mars, but actually was life that we brought there.
What exactly is the scientific value knowing whether or not Mars has life on it?
Well, if you're asking whether there's current life on Mars, I think the value is immense. We've seen in my field of molecular biology enormous benefit and resources in biodiversity. The value of biology and its study has brought us antibiotics, improved crop production, and even resulted in better laundry detergent.
When we look at the red planet today, we see a desert wasteland. But the question is, should we now think of Mars differently? Was Mars another blue ocean planet, primed for life, rich in promise? Is it possible there were others who stood on the shores of Mars? Others who played or savored the Martian sunset. If there were others, maybe they weren't that different from us. Maybe the question isn't what turns a blue planet red, but rather, how can we avoid the same fate?
The problem is a lot of times scientists are so entrenched in what they think they know that they don't realize that often a lot of what we know is wrong. And it takes time to correct these things. We've seen that throughout recorded history.
Question is, do you think we should go to Mars?
Hell yeah.
Why not?
Sure.
Yeah.
No problem from my side.
It's probably pretty good for mining.
Do you want to go there?
Yes.
Yeah, why do you want to go there? Because why not?
To visit?
Yeah. Yeah.
Yes. Why?
To see what's out there.
See what's out there?
Probably not.
Why not?
Probably just stay here.
No, I mean, if it's like getting your kid a pet. If they can't take care of that pet, why would you get him a second one?
No.
Why not?
It's a man's planet. Venus is for women.
No.
Why not?
Other shit we got to do here first.
We're not prepared for Mars.
Yes.
Why?
To meet new beings.
Dude, what's going on? Do you think we should go to Mars?
No.
No, why not?
Cause, man, we out here living in hell right now. Why you want to go to Mars?
Get your ass to Mars.
Expialidocious.
Yes.
Okay.
Is it a real word?
It is now. It wasn't when it was created.
It is now?
Yeah.
How do you know?
Because it's in the dictionary now.
How do you know that?
Am I doing right? He's going to find something here.
Think about the pasties on your sculpture.
Oh. All right, Joey, you always got to bring the pasties into it, huh? This is a family thing.
The first astronaut to land on Mars, the world will know their name for eternity.
So if you could ask anything to Elon Musk, what would it be?
Elon, why haven't you called me?
They're looking for water to see if there's life on Mars. And I've always wondered, what if there is life on Mars, but it's teensy-weensy? And we're just crushing it with our rovers. The camera on the front, everything appears to be dry and desolate under the wheels.
So what about the moon? What's going on with the moon?
I've been asked not to talk about the moon. They said I can talk about Mars all I like. Just don't talk about the moon, John.